Hello everyone, this is Manjunath Ayal. In this video, I'll be explaining the graphical user interface of ANSYS software for structural analysis. So let us open the software which is already installed in the beginning. So this will be the welcome window. And in this one you have to select the type of license, that is ANSYS structural or mechanical, whichever you want. So you can select ANSYS structural from the drop down menu. You can see here and you can select it, and then you can change the directory where you are working and you can give the name. Okay, so I'll be just giving this as demo and click run. Okay, like that you should open and create the structure. So for demonstrating purpose, what I'll do, I'll open previous version, previous file which we have, previous example which I have worked. So that you can do it by open, and I have a problem, cantilever beam problem, and I'll open that so that all the options will be available. Otherwise some features will not be shown before creation of nodes and elements. So this is the graphical user interface of ANSYS software. As usual, just like another structural analysis software. So these are all the toolbars which will be there. This is the file menu. The main tools available. File menu, select menu, list, plot, all these things, plot elements, plot controls. You will be understanding these things later. So I will touch upon mainly on the geometry creation part and the steps involved in the analysis of any structure, right? So initially, after you open, you have to save the database with that name, and then so this is the main window where you will be working in the software, and this is the views view toolbars, which will be enabling you to view isometric view, front view, side view, all that, zooming, etc., etc. So this is the main window where everything will be controlled. So to start with, after you open the file, to start with, you should click this, and you should mention the preference GUI filtering you want. Okay, ANSYS structural you can switch on, so that the things which are required for structural analysis will be highlighted here. Okay, and then so in this modeling, solving problems using ANSYS, mainly consists of 3 steps: modeling, pre-processing, and post-processing. The pre-processing and modeling will be available, both options will be available in this tab. So we'll just take up one example. I can show you. So if you just take a cantilever beam like this, so where you, actually speaking, if you are solving manually, you will be finding the bending moment diagram, shear force diagram, finding the support reactions, etc. Okay, by giving the cross sections. So if it is a simple one, you can directly do it by equations of equilibrium only: sigma fx equal to 0, sigma fy equal to 0, sigma m equal to 0. But if it is a complex one, you could use complex problem, like if the degree of indeterminacy is more, you'll be using moment distribution method or Carney's method, so many other methods, and also matrix method of analysis. So basic thing we will be finding the support reactions, bending moments, shear forces, etc. So in this the same thing, manual analysis we do in when we do manually. So same thing can be done using software also. Here the thing is, because we will be using software or system, so you need to make the software understand the problem. Okay, that part will be called modeling. So that modeling will be doing here in this process. So we need to, modeling is nothing but specifying the lengths, dimensions, what is the type, what is the end conditions, what are the loads, and later on we can give we need to get the results, etc. Okay, so initially we will create the geometry. So in order to create the geometry, you need to go to modeling, post processing. Before that, Before that, we need to mention the different types of element. In finite element analysis, everything will be done as finite elements. So this problem can be solved by so many other ways. So by using line elements, beam, that is beam elements, or you can also model this as a solid element. So these both methods we will be doing in future. Okay, so the same problem with can be solved in different ways. Okay, so how simply you wanted to solve, or what is the importance of the problem, depending upon that we will be choosing the type of element. Okay, so that element type we need to do it, select from here, add elements, and you can see add, there will be different types of elements which will be available in this one. Okay, and depending upon your problem you need to add the different element to your current work, and later required the real constants you need to give it from this real constant option, like if you have like thicknesses, cross section dimensions, they may be particular to the different particular element. So sometimes real constant may not be required for the given elements, so which you will be learning in the future. And then after giving the real constants, you need to give material properties. So material properties, usually that's nothing but the Poisson's ratio and Young's modulus, all those things, densities, etc., etc. So those things we can we'll get it from this material models: structural, linear, and elastic. And from here isotropic you can select, and you can enter Young's modulus in the x direction and Poisson's ratio. And I have entered for concrete, and just click OK, and it will be saved, and will be there here. And during meshing we will be selecting element, we will be assigning this element types and material properties to the these members. Okay, and for some elements, for some element types you may need to mention the cross section dimensions also. So there, if in that case there will be different types of cross sections which will be available, and you can choose these, and you can assign. And later on, after giving the sections, modeling thing which we need to do. So this ANSYS basically works based on the principle of key points, lines, areas, volumes, then nodes and elements. So initially these key points, lines, areas and volumes are nothing but the skeleton part actually, which may not actually involve in the structural analysis. They're like a background, and that background will be creating nodes and elements, and these actually, the nodes and elements will be involved in the structural analysis, or so they will be analyzed and the forces and etc. will be transferred to nodes and elements, and also the results will also be tabulated or mapped to these nodes and elements only. There is nothing to do with these key points, lines, areas, volumes. All these things are nothing but the background. Okay, just like what we do in the let us say, for example, in tracing kind of things. Okay, so that will be a original one, background, and that one we will be creating nodes and elements which will be involving in the structural analysis. There is nothing to do with this. This is just a geometry creation part. Okay, so then creating after we'll have to create first key points, and usually key points you need to do it just nothing but the if you have this beam, so you need to create a key point over here and one here, and join this by a line, and on that line nodes and elements has to be created. So you need to give the coordinates for this 0, 0, 0, and this one will be 2, 0, 0. So that is what you should do here. So by clicking this work plane, you just need to 0, 0, 0. If you enter, one node will be created. 0, 1, 2, 0, 0. If you click, there will be another node which will be coming, and you should join, and so that line will come, and that line has to be given the number of elements to be added, and that has to be done by using meshing. After you create the line, so we need to do meshing, and in that meshing we will have to map the real element types, real constant, material properties, and cross section dimensions, everything over here. So for which what we have to do is we need to select picked lines, and if you select picked line and click apply, so what are all the element types, material models which we have created, all these will be available, and based on our requirement we will be assigning those things. Sometimes you may have, if you have more than more than one beam, so if you have two different cross sections, there you will have two different cross sections here, and you can select one out of those which is proper, which is actually applied to that particular beam. So from here we will be assigning or mapping the element types, real constant, material properties, and sections to the member. So that is called meshing. So that in that we will be using this mesh attributes for assigning. And after mesh attributes, we need to give size control. Size control means we need to give the number of elements in the finite in this space, actually continuum. So this actually works on the finite element analysis, finite element principle, matrix analysis. So we need to divide the given continuum into finite number of elements. So more the number of elements, more the accurate results. So likewise we will be dividing, and to divide that, so we should fix the number of elements. That you can do it from here. So manual size, and you can click picked line and click apply and select that, and if you click OK, and number of elements or divisions you can enter here, and you can click apply, so that it will be divided into number of pieces. And actually it won't be divided now itself. After you do mesh tool, and if you just click mesh, okay, yeah, here mesh, then only just click select this and click apply, then only it will be meshed. Now initially it is already meshed, so it need not mesh again. So next problem, next video you will be understanding the steps involved in the actual problem. So this is only main steps or procedure I am explaining in this video. So after giving the meshing, so your nodes and elements will be created. Just see here, so these are the nodes and elements which are there, and afterwards what we need to do, we have to create the supports here. And in order to create support, actually now till just we have created nodes and elements, that's all. Now we need to specify where is the support is and what is the load acting on their structure, and afterwards you need to solve the problem and you will be getting the results. Okay, now so we need to mention the type of analysis, new analysis, static analysis you can mention. So different types of analysis depending upon problem which you are considering, you should choose. And afterwards you need to apply the loads. In apply loads you can see the structural, and here, so for creating the supports you click displacements and on nodes, and click here and click apply, and you will have different degrees of freedom which you need to restrict. So for a fixed support, all degrees of freedom should be fixed, or for depending upon the, or if it is a simply supported beam, only UI has to be restrained. But since it's a fixed one, so we'll consider all degrees of freedom and click OK. So all the directions are fixed, and afterwards you need to apply the forces, and we'll just consider 150 kN force acting downwards at the last point. Click nodes. Okay, so to do that, actually you just need to click nodes and select the node wherever required and click apply, and direction you need to mention, so maybe 50 Newton, whatever value is required you can enter, and click apply. Okay, so automatically the load will come. So we have done with the modeling. Now next thing we need to do is we need to solve the problem. So go to solve current LS and click OK. So solution will be done, click close, and afterwards what you need to do is we need to view the results. Okay, so to view the results, go to general post processing, and then we need to first read the results. So first set you can click, and afterwards we need to plot the results, and you can plot the results by here. Different types of plotting will be done here. So contour plot. So initially if you want to see the displacement diagram and maximum deflection, so go to nodal solution, and you can click degrees of freedom and y component forces, y component displacement you can click and click apply, and you can see how exactly it is displaced. And if you want to see both deformed and undeformed, so this is the undeformed and this is deformed shape, and maximum displacement is happening at this point, and which is equal to 2.42 mm. and this is the deflection diagram. And now if you want bending moment diagram etc., or bending stress etc., maximum bending moment diagram, you can go to the element solution, and here in the element solution we can go to structural moments and moment about z direction and click so both undeformed and apply. So you can see the bending moment diagram. Okay, 100, so maximum is 100 here, so which is happening here, maximum mn point. So we know that 50 wl by 2, 50 wl by w into l, so bending moment will be w into l, so force is w, p or w is 50, 50 into 2 is 100, so 100 is the bending moment at this point. And if you want to get a bending moment diagram, what you need to do is we can define the element table. Okay, so go to element table, such, so this is one of the example. So same thing, same way you can do anything. So we can just for a bending moment diagram define element table, and here what you need to do, add. So go to last step, and here by sequence number you need to mention SMC3. This is for maximum bending moment, bending moment in the elements, and click add. Similarly, for if you want shear force, click add, last option by sequence number SMC6 you can give, and that will be the shear force diagram. After you click add, so both will be available here. And for plotting, what you need to do, plot results, last one in the contour plot, line element resolutions, you can select SMC at node 1, node I, and node J also SMIS3, and click apply. So you can see the bending moment diagram which is happening like this. It's a linear variation because it's a point load, linear variation, and it starts from 0 to 100. So this is how the bending moment diagram will be plotted using the contour plot and line element option. Okay, so these are the basic main steps involved in any analysis. Okay, so this concludes the demonstration of the ANSYS software, or graphical user interface of ANSYS software. Thank you.